All right, back to the water problem. Let's find the expected value of the amount of water we're using a day. First of all, I know that I'm going to use no gallons with a 25% chance, and then plus, let's see, how would I do this normally? If it was a continuous variable, I'd integrate the dummy variable, representing the variable of interest, against the density function. I've already determined that that sort of the remaining part that's not discrete, that sort of where we have this density function part, is 2 times 3/4 over a million, right? W dW. Okay, so this part right here is sort of like your density function part. Okay, so this first part is just 0, of course, and then plus I guess that's 1.5 over a million times the integral of W squared, just W squared dW from 0 to 1,000, and I guess that works out to be 1.5 over a million times 1,000 cubed over 3, and let's see, that comes out to be 1.5 times 1,000 to the third divided by 3 divided by a million is 500 gallons. Yeah, it's got units of gallons on it. Okay, great. So you can see what we've done here. We've got a continuous part and a discrete part. Great. You can see, thinking that this way that I've showed you, you can sort of see, we've got 25% of it's discrete and then 75% of it's continuous. Okay, if I get rid of this 75%, if I just get rid of this, then what I'm left with here is I'm left with this integral that is basically, if I change my distribution to where I'm not using 0 gallons, and if I assume that I'm always using at least some amount of water that's not 0, then this is my new expected amount of water. If I just remove this 0.75. Tell you what, let's take another stab at this expected value. There's another way to do it that I think you're really going to hate, but it's really slick. I'm just kidding. You'll love it. You're going to love this. Do you remember when we talked about discrete random variables? We said that if W was non-negative, then you can express the expectation as the sum of the probability that it's greater than some number. Okay, or in the case of it being continuous, you can express it as the integral from 0 to infinity of the probability that W is greater than W dW, something like that. Okay. Whoa, look at that guy. We got a little visitor. What is that thing? Jeez. Okay. Well, yeah, this is true even in the case of when we have mixed variables, as long as W is a non-negative random variable. Okay, what this is now in our new notation, we can write as the integral from 0 to infinity of well, let's see. I guess maybe I just want to keep it like that, right? Maybe I'll just keep it like that. W greater than W dW. Okay. Yeah. Good. Just like that. Okay. Now let's take a look at our picture. Remember this picture? Okay, this is our picture. Here's I've drawn on it a little bit, but this is our CDF, right? This is our new CDF function. Now, what this says is that my expected value is actually just it's this area right in here. If I integrate from 0 up to infinity of the probability that this random variable takes on a value greater than a certain amount, it's just the area in this region. Okay, isn't that great? Okay, so this is a really terrific way to think about the expected value of a random variable that's non-negative, of course. It's non-negative. It's just the area between 1 and its cumulative distribution function. So another way that I could get this then is I could just take the total area of this rectangle here, which is 1 times 1,000, and subtract off the area that's down here in this funny shape. Right? So maybe I'll try that. Let's try that. So this is going to be 1 times 1,000. Okay, I'm going to subtract off the integral from 0 up to 1,000 of a quarter. Right? I'm just going to put in what my CDF is in there. A quarter plus 3 over 4 million. 4 times 10 to the 6th, right? Times w squared dw. And this turns out to be 1,000 minus, let's see, I guess this is going to be a quarter w plus 3w cubed over 3 is just this 46, right? 0 to 1,000. Okay, so this is going to be 1,000 minus a quarter of 1,000. I can do that in my head. That's 250 plus 1,000 raised to the third over 4 million. All right. Okay. So what does this turn out to be here? It should be 500. Let's see. Let's see if it is. Right. 1,000 minus 250 plus 1,000 raised to the third divided by 4 million. 500! Fan-freaking-tastic. Same as it was over here. Okay? So there are a couple ways to do that. Both are really great.